Good morning, all of you. My screen is visible. Anybody? Hello? Anybody? My screen is visible. Hello? Nobody is there?
Yes, sir, visible, sir.
Why this much time you are taking? I don't know. What is the problem? When I ask, somebody can respond, no? Is there any problem?
No, sir.
80 members are there. Nobody is responding. I am oftenly asking. Immediately can respond yes or no. That's all, no? Okay, see, today we will go to series and parallel operation of SCRs. And why series operation, parallel operation, and what are the problems arise in that, how to overcome that problem. So that is the thing we need to discuss today. Briefly, I already explained the introduction chapters as well as the previous class. We'll see series operation first and then move on to parallel operation. So each SCR rating is 10 kV and 3 kiloamperes are available. Even more also there. Just for example, I am saying that there is a voltage level of each SCR is 10 kV and current is 3 kiloamperes or 3000 amperes are available. In industry application, demand for voltage and current ratings is more than one SCR rating. In such cases, to meet the demands, we need to go for series and parallel operation. Series means automatically to meet the voltage demand, and parallel is to fulfill the current demands. String efficiency is the term measure the degree of utilization. So here the thing is based on your demand, either it is in the form of current demand or in the form of voltage demand, whether you are utilizing properly the devices or not. Based on that, we can define the string efficiency. This also I mentioned in the previous class definition also. It may be both series or parallel. The formula, when you want to discuss with series operation, then you can use the voltage rating. And if you use as a parallel operation, the string efficiency formula we can use as a current. But in general formula, I will make use of voltage and current. Then the depends on your problem. Use that formula, either voltage value or a current value. Depends on your what you call it as voltage rating or a current rating for your formula. And suppose if any case my voice is not audible, let me know. And we see the formula. There is a string efficiency, actual voltage or current rating of the whole string divided by n number of SCRs in a string. It may be series or a parallel, and individual voltage or current rating of the one SCR. So here the formula is very straight away. Suppose if I want to represent in the series operation string efficiency, then you can see that actual voltage rating of the whole string divided by individual voltage rating of one SCR into number of SCRs are in series. That is the formula for string efficiency. Suppose if it is in the parallel operation, actual current rating of the whole string by individual current rating of one SCR into number of SCRs in parallel. So that is the normal string efficiency formula. In practice, the ratio is less than 1. So that we'll see that in general, it never reaches to 1 because of their characteristics is not identical and all. obtaining highest possible string efficiency, SCRs connected in series. Hello? SCRs are connected in series or in parallel string must have identical characteristics. If both SCRs, not only two, it may be more than two or maybe 10 or 100 or anything. If all the SCRs having identical characteristics, then the ratio is unity. Preferably, it will be less than 1, it will get it. But if it gives more value, that gives as a high utilization factor. The same rating, same specification, even though if you are using the SCRs in a string, whether both operation, it may be series or in parallel, if the characteristics, rating and specifications are also the same, but there is a VI characteristics must be identical. If it is not, then there is a voltage sharing or a current sharing may not be equal. Our intention is to make voltage or a current sharing in a string must be equal. That is only our requirement. That is, but here what will happen, having identical characteristic, unequal voltage and current sharing is bound to occur for all the SCRs in a string. Therefore, string efficiency never be equal. So, to make equal, what we need to do? So, that is the next question. So, unequal voltage current sharing by the SCRs in a string can be minimized to a great extent by using external equalizing circuit. So, the problem is here, the why unequal voltage or current sharing is going to take place, and to make it equal, what we need to do? That is only the two things is required in this aspect. But the one problem we identified, even though specifications and rating of SCRs are same, but VI characteristics may not be the identical. So due to that problem, we are able to getting unequal voltage or current sharing. So now in a string provide with external equalizing circuit, string efficiency is less than unity only, but to make it equal voltage sharing, you can see that one extra unit is added in series or parallel string. Voltage current shared by each device would become as a lower than its normal rating. Now, the use of extra unit will certainly improve the reliability of the string. Obviously, there is a cost will increase. So, what is the term of reliability is here? If you use properly or select the number of devices in series or in parallel, to failure will be minimized such a way that, and also shared by each device will be minimum, so that the failure of the device will get minimum, then the improving the reliability, that aspect. But how many devices need to connected in series or in parallel will decide that, and what is the extra circuit we need to add with the string. That you can see one more measurement parameter is here, reliability aspect. Here the reliability term will lead to the cost aspect, will be more when compared to the normal case. If you required more reliable, more number of devices need to connected in series and parallel. The reason is to get more reliable, instead of operating the device in a higher rating, you are trying to use less rating, less sharing, so that device will not carry the rated current or rated voltage. So that in the thing, if any device, even machine, you can take it our lab machine or something, the probability or a chance of getting failure or maybe losses are more when you operate the machine in the very high load or a full load condition. But if you try to operate that is in the less load condition, then the chance of getting failures are minimum. Then if you are operating machine under low load condition, but to meet your demand, you may need another machine to meet the demand. So that's why this the term, what I mean to say is, instead of carrying the full load current, if you are trying to carry the less load, the failure will be minimum, so that reliability will be more. Same aspect in the case of thyristors also. To carry 100 kV, let assume that each SCR is 10 kV. We need to connect 10 SCRs in series. That means each SCR will carry the 10 kV voltage. It block that voltage. But whereas instead of 10 SCR, if you use 15 SCR, then what will happen? What is the improvement there? One aspect is reliability will be improved. Instead of using 10 SCRs, if you use as a 15 SCR, reliability will be more, because instead of carrying full rated voltage, it carries the less voltage, then the reliability will be more. But what is the drawback if we use like that? The one drawback is, instead of 10 you are using 15, so the cost of the setup or cost of the string will be more. Once one thing we want to meet, another thing has to be sacrificed. So the thing is, if you are using more cost, then reliability will be more. That is the formula here. You can see that reliability of a string is given by the factor called derating factor. That means 1 minus string efficiency is equal to the derating factor. If the value of recommended derating factor is more, the number of devices used in the string will be more. That's what I mean to say. So if the derating factor is more, means reliability will be more. Reliability more means you need to use more devices. That is the thing. And this will certainly improve the reliability, but also cost will increase, because we are using as a more number of devices. That's why reliability will improve, obviously. Then in turn, cost also will improve. Now that is what the basic phenomena. Now we'll move on to the series operation, then we'll go to the parallel operation. In a series operation, you can see here n number of devices. Just I shown you two, just for example, two devices, SCR1 and SCR2. What is the blocking voltage of one? V1. SCR2 is V2. Then total string voltage is what now? Sum of this. In general, it is a 2V1. Let's consider V1 and V2 are same. If it share equally, then V1, V2 are same. Then total blocking voltage is 2V1. If it is both are same voltages. Now if I draw the characteristics, if I draw the characteristics of SCR1 and SCR2 in the same graph sheet, we can notice one thing. Let the dotted line is SCR1 characteristic, and other thick line is SCR2 characteristic. Forward blocking characteristics. You can see here there is a two things are there. This one is a forward blocking characteristics. Once the device is on, it rapidly drop down the voltage and increases the current. So that is a forward conduction. So this graph will give you forward blocking voltage and forward conduction voltage. Now if you see this, whenever if I connect two SCRs are in series, if I draw VI characteristics, then the leakage current, let you can see that I0 is a leakage current passing through that, because both are in the off state, no? When the device is off state, only junction J2 is reverse bias, rest of the junctions are forward bias. That's why you can see that small leakage current will pass through that. That current I make it as I0. If I draw a line horizontally, I0 line, then what we noticed here, the thick line, this point, is a SCR2, this dotted point SCR1. By observing this plot, what is observation? V1 is more voltage, V2 is less voltage. So, actually, both have to share equally. SCR1 and SCR2 voltages must share equally. But due to some problem, I will say that problem. If I want to calculate the leakage resistance, see this one is a leakage current, then if I consider leakage resistance of SCR1, what I can write the formula? R is equal to V by I. I is a I naught, V is a V1 for leakage resistance 1 of the SCR. Similarly, SCR2 leakage resistance, what is this formula? V2 by I naught. In that, I naught is fixed one, leakage current of that two SCRs. Now, V1 is more voltage than V2. Then which one will give as a high resistance value? We can see that V1 by I naught and V2 by I naught, in that ratio if I take, because denominator is fixed one, numerator is which is I, that will give as a high leakage resistance. Then obviously SCR1 having high leakage resistance and SCR2 having less leakage resistance. Because of this leakage resistance of SCR1 is high, that will block the high voltage, because that will leads as a drop, no, that is only the blocking voltage. So now that is the reason SCR1 carry the more voltage or blocking the voltage is more and SCR2 will be less. But I want to make it equal. What I have to do? Anybody can answer this. Now we identify the reason behind unequal voltage sharing. But how to overcome that problem? One reason we identify at this moment, because of leakage resistances are different, it is sharing different voltages or it will block the different voltages. But I want, according to this, total blocking voltage, string voltage, instead of 2V1, normally if both is same, it must be 2V1. But now, how much it is blocking? V1 plus V2. It is blocking V1 plus V2 instead of 2V1. That is the problem actually. Now, to overcome this problem, what I have to do is to make this resistance across the each device or each SCR, if you make it same, then what will happen? Automatically each SCR will share equally. Now how to make it equal resistance across that? Now you know already what is the value of leakage resistance of 1, leakage resistance of 2. To make equally, what I want to do is you connect one SCR in parallel with that each SCR. Then what is the value of this resistance I have to connect? To make this junction resistance must be same. What I want to do is this resistance and this both are in parallel. So if both are in parallel, that paralleling resistance must be, make it same. So then only you will get equal voltage sharing. So how to make it same? Because this value is one value and this is another value of the resistance. To make it same resistance, here we need to connect one resistor value, that paralleling must be same as this paralleling, and so on and so forth. So here is one resistor I have to connect it in parallel. To make it this branch resistance or paralleling resistance is same, and to make this paralleling resistance is same. So each SCR across one resistor you need to connect in parallel with different values. But if you do that way, that is a complicated to identify what is the suitable resistor I have to connect in parallel with the existing resistor, because some cases I need to add the more number of resistors, then again the resistor values will differ, and I have to remove the one of the SCR. Depends on your demand. Voltage demand is varies, no, it may not be the fixed in the particular instant. That may be one value you may be need, later something other may be required, like that. In the different instant you may get different values. So that's the problem again. But one problem is unequal sharing because of the leakage resistors are different, and another one. So now we can see another one. There is a another problem is resistor we are to connected in parallel with different resistance value. That is also another problem. So to overcome this, I want to find one common solution. You derived one resistor value by considering the leakages, by blocking voltages and drops, all total string voltages and number of SCRs are in series, by taking inputs of all the parameters, make use of that and derive one expression such a way that that value must be the same for all the SCRs are in series. So if we connect one uniform resistor in parallel with the SCR, so that voltage shared by each SCR going to be the same. So I want to derive that expression. So now we'll see that. Whatever I explained so far, I given some small points. System voltage is more than, why we are going to series operation I'm explaining here. Voltage is more than the rating of one SCR, then we need to connect SCRs in series in a string. Then SCR should have VI characteristics as close as possible. So if the VI characteristics are different, what we notice is that voltage shared by each SCR is going to be different. So that is the one problem. And on account of inherent variations in their characteristics, voltage shared by each SCR may not be equal. That also we noticed in the graph. So SCR 1 will share the V1 volts, 2 is sharing the V2 volts. For instance, 2 SCRs I consider, it may be any number, and the leakage resistance of 1 is V1 by I naught, and SCR2 is a V2 by I naught. And that shows that SCR1 support the rated voltage, let it be high voltage V1 volts, but SCR2 will support or it block only the less voltage when compared to the V1. And then blocking voltage of V1, which is always less than the forward bracket. This is also very important statement. Rated for a forward blocking voltage of V1, which is always less than the forward breakover voltage. If not, what will happen? If suppose blocking voltage is more than the breakover voltage, what will happen? Automatically device will break down, means device will conduct. But when the device need to conduct, whenever you want to give the firing pulse, only at that instant only device has to fire. But if your blocking voltage is more than, or sharing voltage is more than our VBO, breakover voltage, automatically device will start conducting. To overcome that drawback, what we can do is that voltage, blocking voltage must be less than the breakover voltage. That is the sentence here. Two SCRs can support a maximum voltage of V1 plus V2 and not the rated blocking voltage. What is the rated blocking voltage? 2V1 if it is same, but now it is blocking only V1 plus V2. That is the problem. And now To overcome that problem, uniform voltage distribution we need to make it. For that, what we have to do? So, suitable resistance across SCR, whatever I already explained, same thing only I am mentioning the points. So, each in parallel combination of the same resistance. So, that we want to do it. This will require different value of resistance of each SCR with difficult proposition. So that means one leakage resistance of SCR1 is different, SCR2 is different. That's why what we want to do is that is the paralleling of that resistance is make it same. It is a difficult task of each SCR calculation. That's why what I want to do is in the practical way obtaining a reasonable uniform voltage distribution under steady, this is the point you need to remember, steady state condition, not in the during off condition. It is only during conduction operation, means under steady state operation. But during off, that we call it as a dynamic case. We need to take care of further instance, yet moment what we are discussing only under steady state condition. So a shunt resistor R across each SCR we need to derive. That is the uniform resistance you have to connect in parallel with the each SCR. So that uniform resistor R we need to calculate. That is what R is called a static equalizing circuit. There is a two circuits are required while you are operating as a series and parallel operation, especially under series case. One is under steady state condition, we required one circuit, that is a static equalizing circuit. Another one during during dynamic condition case, means during on and during off, we required as a one operation, that is a dynamic equalizing circuits. We need to consider one is static, another one is a dynamic. So now for that R I want to derive. So for considering all the aspects. So uniform resistor R, I have to connect. You can see that I taken as a n number of SCRs are in series. There is a all resistors are same value, but I want to find what is the value of this resistor R. That if you derive automatically, that value if you connect parallel with that each SCR, automatically we can able to get it equal voltage sharing. For that, what I am taking is n number of SCRs I connected in series, and I divided two parts. One part is only one SCR, other part is remaining SCR. What are the remaining? Total n means one is first one, remaining is n minus 1. So I consider leakage current of one SCR is IBMN, that is a maximum leakage current, and I can say that first leakage current of the SCR1. Remaining n minus 1 leakage currents I consider as a IB max. So therefore voltage, how will you get the total string voltage? Voltage across the SCR1 plus SCR2 plus SCR3 and so on. So instead of adding that, I divided as only two parts. One part is only one SCR, other part is remaining n minus 1 SCR. So this one part I can consider voltage across this is a VBM, and remaining n minus 1 SCR voltage drop I can consider as a I2 into R plus I2 into R. But now what is this? Total drop is of each will be the same, no? Because same current I passed here, I2. Then what will happen? I2R plus I2R plus I2R. Then what is the total drop? N minus 1 into I2R. What is this drop? I1 into R. Let I consider I1 into R is a VBM, maximum forward blocking voltage. VBM is nothing but a maximum forward blocking voltage. So I1R plus N minus 1 into I2R, that is equal to Vs. So now I simply just networking. Now you can see that SCR1 has low leakage current, and this is I am assuming simply. Another n minus 1 SCRs are a high leakage current because remaining are more SCRs, and voltage across SCR1 I consider as a VBM, and remaining n minus 1 SCR voltage drop is nothing but a n minus 1 into I2R. If I want to know what is the total string voltage, I can add these two. VBM plus n minus 1 into I2R. That will give as a Vs. So now from this, Vs is equal to VBM means first SCR plus n minus 1 SCR. That is equal to n minus 1 into I2R. So like that, we can simply derive this. You can see that Vs, what is the first drop? I1 into R, that is nothing but a VBM. So just I will write first I1 into R plus what is other drops? I2R plus I2R plus I2R and so on. How many we have like that? N minus 1. Therefore, N minus 1 into I2R. What is I1R? I consider VBM plus N minus 1 into I2R, that I can write it as a N minus 1 into R. What is I2? You can see the total current is I. One current is passing through I1. Rest of the current pass through I2. So then the difference of this I call it as a, we can see this total leakage current is a IB maximum. Then what is the I2 value? You can easily identify I minus this leakage current will go to the remaining. Is it clear? Total I, it's going, see that series current is same, and here is I. Then I want I2. How much this current? This total I is wasting something leakage current. I call it as IB maximum. Remaining current pass through the I2. Therefore, I2 is equal to, we can see that I2 current is equal to what I can write? Total current minus leakage current. Total current is I minus what is the leakage current of this? IB max. That's all. That will give I2 is equal to I minus IB max. So then automatically I mention here is a R into I2, I minus IB max. So that is the first equation. Now that's what just now I mentioned. I2 is equal to I minus IB max. But what about I1? This leakage current is IBM, no? I minus IBM will give as I1. So now I know I1, I know I2. Then if I subtract this, what will get? I1 minus I2, that is equal to, this will get cancelled, IB max minus IB min, that is equal to, I can represent delta I, difference of that. So that only I mentioned here. You can see this. Now just I replaced that VBM plus n minus 1 into R, then I1 minus IB max. I can write, you can see that I1 minus the different IB max minus IB minimum. So that I can represent as a delta IB, difference of that. So delta IB is nothing but IB max minus IB min. Then you can simplify this. Vs is equal to VBM plus n minus 1 R into I1 minus delta IB. And now from this further, I can simplify that VBM plus n minus 1 into R. What is I1 minus delta IB? According to this formula, you can just simplify that. We can able to get it. What is the R value? Just only the simplification. Now you will get R is equal to N into VBM minus Vs by N minus 1 into delta IB. So you know the number of SCRs, you know the what is the string voltage and what is the difference of that leakage currents. So if you know all the parameters, by make use of that. But one parameter must and should number of SCRs. Based on that also, your resistance value is going to be different. So now this is the value I have to connect in parallel with the each SCR. Any number of SCRs you can connect it in series, but this value if you connect in parallel, the voltage shared by the each SCR will be the same. To do that only, we made it as a equal. That's what I mentioned here. R is calculated. R means this value. NVBM minus Vs by N minus 1 into delta IB. And once the value is calculated, R value, power rating of the VR, that is RMS voltage, across R, we can see that this is a power rating. PR is equal to V square by R. So, SCR do not have identical dynamic characteristics as well. What we overcome one problem, if SCR under static condition, there is unequal voltage sharing of each SCR because of the leakage currents or leakage resistances are different. To make equal, I made it across the junction resistances are same, so that voltage shared by each SCR is going to be same. For that reason, I make it one uniform resistance derivation. That value you have to connect it in parallel with the each SCR, then automatically voltage shared by each SCR will be the same under steady state condition. And second one, we can see that under dynamic conditions, what we can notice that there is also there is a it is not having as identical dynamic characteristics. So in that case, series connected SCR will have unequal voltage distribution during the transient condition. So what is the transient condition here? During on process, during off process, so there is a voltages are unequal. There is voltage are unequal, but that condition also you have to address because the operation may not be steady state. When the device is adding or device is removing, there is a what you can call it as on process and off process also we have to make it equal voltage distribution. So dynamic characteristics of two SCR during on and during off both cases, SCR1 and SCR2 also will not be the same voltage sharing. There is a SCR1 turn on time and turn off times also we have to consider. So we'll see that turn on time of SCR and turn off times of SCR2, 1 and 2, turn on times are different or turn off times are different, what will happen? That also we'll notice now. Before these two SCRs are turn on, that is gated means on condition, string voltage is shared. Normally, a device in the off condition, two SCRs are in series. What is the voltage shared by SCR1 and SCR2 by connecting one resistor in parallel with the SCR? What we can observe is you can see that this is a Vs by 2 and this is a Vs by 2. Then string voltage Vs. Total voltage is a Vs. In that Vs, this will give Vs by 2. This will give Vs by 2. Let's consider total string voltage is Vs. It is sharing equally. This one is Vs by 2 and this one is Vs by 2 before turn on the device. Once the device is offset, blocking voltage is Vs by 2 and Vs by 2. Now, what we can have is that SCR1 has less turn on time. Let's consider if this situation is arise, because two SCRs I am considering, 1 and 2. If SCR1 has less turn on time means what will happen? It will turn on first. So SCR1 turn on time is less and SCR2 is a turn on time will be more. Let's consider it gets turn on first. It is less turn on time means SCR1 will turn on first at some instant of t1. SCR2 is not at turn off. So because we can see that voltage across SCR1 drops to Vs by 2 to almost 0. You can see very simple logic. These two are in series. Both are sharing equally. Vs by 2 Vs by 2, and this is Vs by 2, and this is Vs by 2. But now turn on time is less for SCR1. Then what will happen? This will on first. Once this is on, what is voltage across this? Anybody? This voltage across this is a Vs by 2 initially if it is a open state, but now if it is a closed, then this voltage is near to the 0. Now this is on automatically, but this still SCR2 is open, then what is the voltage across SCR2? Anybody guess this? Very small logic. Anybody answered this question? Initially both devices are open state. It is blocking Vs by 2 and Vs by 2, and I am trying to turn on the device. First device turn on time is less, that's why it will turn on first. Once if it is turned on first, then voltage across that will be the 0, because once the device is on, voltage across that will be the 0. And what about the second device voltage? This will be, it is already short now, total string voltage will appear across the device too, because it is open. This anode is directly connected here, cathode is directly connected here. Therefore, total voltage across the SCR2 instead of Vs by 2, now it will become as a Vs. Suppose this Vs is more than breakover voltage, then the SCR2 also going to be fire. That is what we need to take care of that. Now we can see that at the same instant T1, voltage across SCR2 will be boost. Instead of Vs, now it will become as a Vs by 2 to almost Vs, means total voltage appear across the SCR2. The voltage shared by 2 SCR is unequal. Is it clear the problem under dynamic condition case? One problem is this. So, if both SCRs are not having equal turn on time, initially, because of the parallel resistor, each SCR is sharing equal voltages, Vs by 2 and Vs by 2, total is Vs. But one of the SCR turn on time is less, automatically SCR1 will turn on first, then voltage across that will be 0, then the remaining second SCR is still in the off state because the turn on time is more. To make turn on, we required some time, that is a turn on time 1 to 4 microseconds, I told in the dynamic characteristics case. So what I want to do is, I make it on, it will require some time. If that time is more, the second SCR will be remains in the up state only. Therefore, total blocking voltage applied across the SCR2. That is the problem. Now, one SCR is sharing 0 voltage, other one is sharing total voltage. That shared by 2 SCRs are unequal. That is the problem. So that's what we noticed here. Let it be anode voltage, I am telling SCR1 and SCR2. So initially is off state, both is sharing Vs by 2. Whenever we are trying to turn on, you can see that SCR1 is going to be on first, because less turn on time, immediately it will on, it will black that voltage is 0 volts, and but once if it is on, immediately total Vs is applied across the SCR2, then that voltage will be rises to the Vs. Instead of Vs by 2, we are getting as a total Vs. That is the problem here. So that problem, another problem also you can see that turn off time. This is the turn on process different. There is a unequal voltage sharing is going to be takes place according to this diagram. And another problem also you can notice, this characteristics is reverse recovery characteristics. We can see that SCR turn off time, this is on time. Now I am telling turn off time of SCR1 is less comparatively SCR2. You can see that TQ1 and TQ2. You can notice that SCR turn off time of SCR1 is less, and turn off time of SCR2 is more. In that case, we can see that there also unequal voltage sharing is going to be takes place. And how to overcome that problem? Second problem. First problem we totally three problems. Let's consider static condition. One static equalizing circuit is connected across the each SCR. We overcome that problem under static condition. And dynamic condition, two problems are there. One problem is turn on time problem. Another one is a turn off time problem. Now we can see that the instant of that same the previous graph explanation only I wrote here, and that during turn off, now we can see that during off time thyristor characteristics we shown in the second plot. So SCR1 is assumed to have less turn off time, that is a TQ1, and another one is a more turn off time for SCR2. So turn on times are different, also unequal voltage sharing. Turn off time difference also unequal voltage sharing. Now to overcome that, you can see that in the instant there is a SCR1 as reverse recovery and recovered and passing through the 0 volts, whereas so SCR2 is developing a reverse recovery voltage, so some magnitude, and similarly for SCR2. So that leads as a one magnitude is AB, another magnitude is AC. So therefore means the duration I am telling, while the plots is showing like this, no. So that magnitudes we can different, the two SCRs are again sharing unequally. Even turn off times are different. So now that will be different characteristics during off. It suffers from unequal voltage distribution during off process as well. So it may thus be calculated from the above series connected SCRs to suffer unequal voltage disturbance across turn on time as well as turn off time. These are the two another problems we arise unequal voltage distribution during on process we noticed, during off process also we noticed. For that again, what is the problem? That simple resistor across the equalizing circuit cannot be maintained equal voltage distribution under transient condition. What is the meaning of transient condition here? That resistor, whatever resistor you connected across the SCR, that will be fine for static condition. But during transient condition, that the problem is during on state or during off state, if the time intervals of on and off is not same, then again problem will be arise that one resistor itself is not sufficient to maintain in equal voltage sharing. So now we can see that capacitance of the reverse bias junction determines the voltage distribution here. Why I call it as mention as a capacitance, in each SCR there is a junction J2 will be acting as a capacitance. That junction J2 will act as a capacitance. This will be is not in the same, this SCR1 junction capacitance is not same as the SCR2 or SCR3 and so on. Because of this junction capacitances are different, we are able to getting different voltage sharing during dynamic condition. Now to make it same like a resistance, what we want to do is again you connect one parallel capacitor across the each SCR. So that means SCR1 junction capacitance and SCR2 junction capacitance both are in parallel, then the resultant of this will be the same as the all the SCRs. So then again uniform distribution is going to be takes place. That capacitance we have to derive. So for that reason, a reverse bias junction, like we have to different capacitance called self capacitances. The voltage distribution during on and off period will be unequal. That is the problem. The self capacitance of each SCR is not same, and now you connect one external capacitor in parallel with the SCR, so that the branch, or you can say that paralleling of the two capacitance resultant or equivalent of the capacitance of the each SCR must be the same, then you are going to be equal sharing. For that reason, what you have to do is you have to calculate one shunt capacitor value such a way that capacitor, if we connected in parallel, will get it as a equal voltage sharing. During on and during off, the resultant of the shunt capacitance plus in the sense here paralleling of that too, for self capacitance of the each SCR must be the same. Now we can see another part of the circuit. Earlier circuit is this one, what you call it as this series case. What we are using as under static equalizing circuit, I consider this one will be as a, just a minute, this one we can able to call it as a static equalizing circuit we are using. Same thing, you forget about the R and D now. Only one capacitor in parallel with that SCR is sufficient. The resultant capacitance values is same, automatically equal voltage sharing is going to be takes place. So this portion I already explained in the case of snubber circuit. Same thing will come this point also. Now there is a capacitor across that is sufficient. But now let's consider no resistor, and now once the device is off state, what will happen? Capacitor will charge like this, because whatever voltage across that SCR1, that will make this capacitor plus and minus, it is going to be charged. Now if there no resistor here in series with the capacitor, now if I give current firing pulse to this, then automatically current is passing through the capacitor. Once the current is passed through the capacitor, initially it is charging. Once you are trying to give the firing pulse, then this thyristor will on. Once this thyristor is on, already there is a voltage across the capacitor. This is going to be discharged like this. So that will be high current pass through the resistor. To overcome that one, we are using as a one damping resistor. So if I use one damping resistor while it is discharging, it must passes through there is a resistor. Then what will happen? Current is going to be minimized. It will not affect much if you connect as a one damping resistor in series with the capacitor. So that is going to be decreases. Now another one, we can see that there is in parallel with that RC, we are using as a one diode. Why we need to connect the diode across the resistor? Suppose if diode is not there, our function is what? One thing is during off state, means during SCR is off state, capacitor will charge like this. It will charge, fine. And while it is off state, so there is a, while it is off state, what will happen? I'm audible? Anybody? Hello?
Yes, sir.
Yeah. So while off state capacitor is charging, and once if you give the gate pulse, then it will on, then the current is passing through resistor, again it will fine. But the problem is during off state, the charging path will be passes through the resistor now. If I use there is a large resistor, the charging path through resistor time constant is RC, then automatically it will take more time to charge the capacitor. That is unwanted. Then what we have to do? You connect one diode across the resistor. Then while it is charging, what will happen? This is plus, this is minus, no? Then automatically diode will forward bias. While it is off condition, that means SCR is off condition, this diode is forward bias. If diode is forward bias, it will trigger, means it will conduct. If diode is conducting, then the resistor will be short circuited. Then the charging path will be through diode and it goes to the capacitor. While it is discharging, this is plus, this is minus. That's why diode will be open. So it will must and pass through the resistor. So that is what the problem here. Now To make it equal, I used as a capacitor in parallel with the each SCR. That will work fine. But while it is recharging, it will go to, once the device is on, high current pass through the thyristor. That's why we use as a large resistor in series with the capacitor. But the problem is that while charging the capacitor, we required as a more time because of the large resistor. To overcome that problem, we connect one diode across each resistor, then automatically there is a diode will be forward bias, and then automatically it will bypass the resistor. So that way we can overcome this problem. Now the question is, what is the value of capacitor I need to place? The uniform capacitor value I have to place each SCR across that. So we have to derive that value of capacitor. That's what the explanation is given. Blocking state, the capacitor is connected across, it is going to be charged, and SCR is on, capacitor is discharge, heavy current pass through the SCR, and for limiting the discharging spike, then the damping resistor is used in series with the capacitor, and resistor RC also damp out high frequency spikes because of large resistor is placed in series with the capacitor, and that will be one of the advantage. And the combination of RC and C called as a dynamic equalizing circuit. There is a static equalizing circuit, we call it as only the resistor is connected in parallel with the SCR, and dynamic equalizing circuit we can connect one what you call it as RC and C. That means one resistor and then another capacitor we need to connect. That will be call it as a dynamic. And diode also placed across RC, when forward voltage appear across the diode, to bypass that we are using as a one diode. So that makes the capacitor more effective in voltage equalizing and limiting the dV by dt across the SCR. What is the dV by dt? Suddenly supply is given, the rate of change of voltage increases beyond the specified value, device is going to trigger. That's why we need to connect one capacitor across that resistor, nothing but a snubber only. What we are doing is here is a snubber circuit, that is a dynamic equalizing circuit. And during capacitor discharge, we required as RC to limit that spikes and all. And then to turn off time is more predominant than during the turn on time. So there is a problem of charging all these things, that also we'll see now. So turn off time of SCR1 is this one, this time is less, and other turn off time of SCR time is more than the charging. Storing of the charge delta Q, Q is equal to CV formula. You just find that what is the value of C. We need to find that value of C. Series connected SCR, voltage unbalanced during off time is more problem than the on time. Therefore, choice of C is based on the reverse recovery characteristics. That's what just I shown turn off time of SCR1 is less than the SCR2, that is reverse recovery characteristics. We can notice here delta Q proportional to the product of current and time. So, and we can see that what is the value of C. Just small derivation I will show you here. The drop across SCR2 is VBM minus this drop, and here drop voltage is nothing but a Q is equal to CV, and that is nothing but a V is equal to Q by C. So that drop. Now Vs I can write it as a drop across 1 and plus drop across 2. Drop across 1 is VBM, drop across 2 is equal to VBM minus this delta Q by C. So that I will write the equation Vs is equal to V1 plus V2, VBM plus another drop is VBM minus delta Q by C. And now I will show you the relation Vs as usual of series resistor, what we derived for static. V1 plus n minus 1 into V2. What is the V1? That is nothing but a drop across the V1, and this is drop across the V2. Then V1 is VBM and n minus 1 as such. V2 is nothing but a, as per previous formula, VBM minus drop, that is a delta Q by C. And you can simplify that, you'll get it as a VBM. This you can substitute here and you can simplify, finally value of capacitance is going to be getting. So this is the two derivations are very important and problems also important. That is what problem they ask. This is the voltage rating of each SCR, and then you design equalizing resistance and dynamic equalizing components R and C. So these are the formulas we require to derive. That is all about the series operation. And you can see that parallel operation. Why we required parallel operation of SCRs? Anybody? To meet the current demand. Now, if I draw the forward conduction characteristics, SCR1 is like this, SCR same rating only, but now under once both are is on, conduction characteristics means what? It is on. So this device is on, this device also on, then voltage across this will be the same because both are is on state. Voltage drop across or voltage across the SCR1 is same as SCR2. Let it be some value 1 volt or 2 volts. So if I draw one line vertically for that characteristics, what we noticed that SCR1 is carry the more current, SCR2 carry the less current. If these two currents are different, then what will happen? SCR1 is sharing more current than SCR2. That is also problem. I don't want to share unequal current sharing. If any number of SCRs is connected in parallel, all SCRs must share equally. That's what I mentioned here. Current required by the load is more than the rated current. In a single SCR, then we go for as a parallel operation. VI characteristics during forward conduction we drawn, and then if you draw VT line and SCR1 will share the more current than SCR2, that the also problem. Instead of 2 I1, we are getting as I1 plus I2. That is the problem arised once the characteristics are not identical. Now we can see that for simple explanation, n SCRs are in parallel operation. They should get turn on at the same moment and turn off at the same moment. But suppose turn on times are different, then consider SCR1 large turn on time, remaining n minus 1 SCRs are low turn on time. Then what is the meaning? If all 10 SCRs are connected like this parallelly, all must turn on at the same time. But unfortunately, first SCR turn on time is more than all remaining SCRs are same turn on time. Let's consider this is 4 microsecond, remaining SCRs are 3 microsecond. Then what will happen? All this remaining SCRs will on first, but this is unable to turn on. What is the problem? We required 4 microseconds of time, but at the 3rd microseconds of time, all the SCRs are on. Then voltage drop across that string. What is that? Anybody? What is the voltage drop across this string? Because all SCRs are in parallel, if all the SCRs are on except first one, drop across this only 1 to 2 volts. This is very low voltage. So even though to turn on, firing pulse is required, but minimum anode to cathode voltage is required. So this is 1 to 2 volts are below the minimum requirement voltage. That's why this SCR is unable to conduct finally. At 4th microsecond, SCR1 is unable to fire because voltage across anode cathode voltage are very, very small. Because of that reason, the SCR is unable to conduct. SCR1 is unable to fire. So, but load is there. Total demand is 6 to 1. We trying to give the all the SCR as to share, but unfortunately one of the SCR is failed. So one of the SCR is failed. That is the reason SCR1 is unable to conduct. So remaining SCRs will get overloaded. If one of the SCR is again overloaded, consequently this leakage currents are more, and that will lead as a major problem. So that is the reason consequently total string voltage is going to be failure. So there is a problem with that. Now we'll see that how to overcome that problem. So under that condition, n minus 1 SCR will turn on first, then first SCR is unable to turn on, and we can see that across n minus SCR low voltages it is fall down because it is conducting. SCR1 is subjected to the low voltage and hence it will not be turn on. That the finger voltage. Below the finger voltage SCR will not fire because all the rest of the SCRs are on. Voltage across that will be as a minimum. That's the reason SCR1 is unable to fire. If the SCR1 drops to very less voltage, finger voltage, it never going to be turn on. And the remaining SCR will carry the total load, and then there is SCR may be overloaded and damaged because of the heating caused by the overcurrent. Because instead of 10 members, only 4 members do the work, then automatically the overload taking place. Once overload is taking place, it is in the form of heat generation. That is in the form of power dissipation. That will lead to the one of the SCR is going to be damaged. How to overcome this problem? To make that junction temperature is equal, you should not be raise that temperature. So there is a heat sinks we have to provide. That is what I will show you the heat sinks also. Because of the junction temperature rise, dynamic resistance decreases and further the current will increase, and it cumulatively draws more and more current one of the SCR, and finally that SCR also will fail. Only remaining 8 SCRs has to carry the load. Again same problem will cumulatively leads. Then finally what will happen? All the string SCRs is going to be damaged. So to overcome that problem, you have to make it as a temperature must be make it uniformly. So that's what paralleling should be, ensure that operation the same temperature. For that reason, we can place this is the case. Yeah, over ma 2 minutes. It's end. So now you are make it as a common heat sink. If you place like this unsymmetrically, again there is a flux linkage of these three will be not same. This will linkage more flux from this side and this will link more flux, then inductance will be more. If the inductance is more, automatically current shared by this will be less. Again unequal current sharing. That's why what you will do is uniform current sharing will be takes place is a symmetrical arrangement of the heat sink. Now you can see the distance between all the three conductors are same, then the temperature will be the same. That is the problem, and we'll see that next class. Yeah, I think you may have another class. If you have any doubt, you ask me. Otherwise, you can leave.